So this is the second video covering activity 3.9. Again, we're trying to solve equations using logs. So we have the equation e to the negative 0.12t equals 3. So if you look in this example, their first step is they take the natural log of both sides. Anytime I have an e in the problem, I prefer to use ln instead of log because it cleans up nice at the end. All right, so my first step would be take the natural log of both sides. So I'll write that down. So there's my step one. Step two, we can rewrite using properties of logs. All right, there's my rewrite. So that has me bring the exponent in front of my log. So the negative 0.12t, I place in front of the natural log, and I'm left with natural log e. And remember, the natural log of e is equal to 1. Oh, actually, they wrote that right there first. So I can essentially just cross that out, right? Because that's really the equivalent of 1. So negative 0.12t times 1 is negative 0.12t. So how do I solve that for t? Well, if we divide both sides, right? So my step 3 here would be divide both sides by the negative 0.12. And I'm going to end up with t by itself, okay? And again, just to verify with my calculator, I want to do the natural log of 3 divided by negative 0.012. And you see I have negative 91.55, okay? And again, if I wanted to graph this, right? So I know that this is my answer. If I want to verify by graphing, let's say I'm taking a test and I forget how to use logs, or I want to just check my answer. Well, remember, if my original equation was this, I can graph both sides of the equal sign. So I'm going to enter e raised to the negative 0.012x. Okay, so that's the left side of my equation. The right side of my equation is 3. Okay, now listen, we know the answer happens when x is negative 91. So our window is going to be a little funky here. Okay, so when I press window, I'm going to enter negative 100 to say 0, and I'll count by negative, or I'll count by tens, excuse me. Okay, and then for my y min and y max, well, the right side, I'm going to have a straight line at 3, so I'll use a number that's bigger than 3. Maybe I'll just use 10. Okay, so here's my window. I press graph, and we're looking for the intersection. Okay, so there's my intersection. So how do I find it? I press second, trace, number 5, enter 3 times, and you see I have negative 91.55, which is what we found the answer to be when we used algebra or the use of logs. Okay, so let's practice a few problems, right? It says use logarithms to solve the equation. All right, so again, if I'm going to use logs, I have to isolate the exponential. Right? So step 1 is isolate the exponential. Oops, let's get my drawing thing working. So my first step is to isolate the exponential. So if I divide both sides by 75, I'm left with the exponential piece. That's the 0.85 raised to the t equals 12 divided by 75. All right, so step 1 is done. Step 2 would be take the natural log or the log of both sides. All right, so here's my step 2, and it's going to look something like this. I'm going to use the natural log. So 0.85 raised to the t, and then it's the natural log of 12 over 75. All right, step 3 would be rewrite using properties of logs. And so here's my step 3. And all that means is I'm going to bring the t or the exponent in front, and I'm left with t times the natural log of 0 0.85 equals natural log of 12 over 75. So I haven't really done much in that step, right? I just moved the exponent to the front of my natural log, okay? Step 4, solve for t. Right, so here's my step 4. And if I divide both sides by natural log of 0.85, you will see, hopefully, we should end up with the correct answer, right? So when I do that, then on the left side, the natural log of 0.85 will cancel, and I'll be left with just t on the left side. And on the right side, I'm going to have the 12 over 75 divided by natural log of 0.85. All right, so let's try that in our calculator, and we can see our results, right? So I'm going to enter natural log of 12 over 75, and that's going to be divided by the natural log of 0.85. I press enter. Oh, I made a boo-boo. You see what happened? It should be 0.85. So if I press second enter, it brings back the last thing I did. I have to actually now put in 0.85. And my decimal still did not take. There we go. Okay, now I press enter. So my final answer is 11.276. So t equals 11.27. I forgot what the last two decimal places were. 61. Okay, so that's my final answer. If I wanted to check my work by graphing, we could do that. If I press y equals, I'm going to enter the left side of my equation as y1. The right side of my equation is y2. So we expect the answer to be 11.276. So when we set up our window, I'll start at 0, and I'm going to go to some number that's a little bit bigger than 11. Let's go to 15. And the right side of my equation was, what, 12? So I'll use a number a little bit bigger than 12, and we'll call that 15. I press graph, and the intersection should happen at this 11.2761. Let's see if it does. Okay, so far so good. Press second, trace, 5, enter, 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 and look at that, 11.27611, which is what we found, 11.27611. So we've actually solved this twice, right? We used logarithms to solve the problem, and we solved the problem by graphing. If on a test you decide to solve this problem by graphing, please make sure you actually sketch the graph and label the intersection. Okay? Thanks for watching. I'm going to do another video and tackle problem 2. Okay?